Hello students, this is Samudha, Assistant Professor from the Department of Robotics and Automation. Our subject code is MR349 and our subject name is Sensors and Instrumentation. Today we are going to discuss about the Unit 4 different types of sensor like optical sensor, pressure sensor and temperature sensor. Here the optical sensors are the photoconductive cell, photovoltaic, photoresistive, LDR and fiber optic sensor. These are all the optical sensor. And pressure sensors are diaphragm, bellows and piezoelectric tactile sensor. These are the pressure sensors. And temperature sensors are IC, temperature IC, that is thermistor, RTD, thermocouple. So these are the temperature sensor. Here is the acoustic sensor, is the sound level sensor, that is vibration sensor, and flow and level measurement, radiation sensor, small sensor. These are all the various types of sensors. So we are going to discuss, right? So here for our first topic is a photoconductive cell. Photoconductive cell is a light sensitive semiconducting device, which is a semiconducting device. When light falling in a semiconductor, the electrical conductivity will vary. Okay. If we apply the voltage across the cell, that is in the semiconducting device, so the light intensity will vary. So if no illumination, that is there is no light fall on it, then the conductivity decrease. If the increased illumination means the conductivity decreased, right? So this is the definition for photoconductive cell. So next one is a working principle of photoconductive cell. So this photoconductive cell is working by photoconductive effect. So the photoconductive effect means the process of conductivity of semiconductor material changes according to the wavelength. According to the wavelength means the light illumination, okay, and intensity of the radiation. So the conductivity of the semiconductor material changes according to the wavelength and intensity of the radiation. That is, if the light fall on a semiconductor device, the illumination is increases means the conductivity decreases. So this is the photoconductive effect. The photoconductive cell is a two-terminal light sensitive semiconductor device. I will show here. So this is the two terminal. This is the one of the terminal. This is the one terminal. This is the one terminal. This is the two terminal device. Right? The semiconductor materials are made in the form of zigzag strips. Here is the zigzag strips. This is the semiconductor material which is made up of zigzag strips. Okay. So the whole assembly is enclosed in the glass cover or protected in a transparent plastic, right? So this is the glass cover, this is the glass cover, okay, or which is protected by the transparent plastic. So here is the two material, one is a cadmium sulfide, another one is a cadmium selenide. These are the two material which is used to manufacture the photoconductive cell. Okay, here nowadays other materials like lead selenide and lead telluride are also used in the manufacturing of photoconductive cell. Okay, so this is the two terminal. So this is that semiconductor device which is made up of two material. One is a cadmium sulfide, another one is a cadmium selenide. We can use any one of this material to manufacture a photoconductive cells. Okay, so this is the symbol of photoconductive cell. This is the symbol of photoconductive cell, which is same as the resistor, but there is a two arrow mark to indicate the photoconductive cell. Okay, so here is the photoconductive cell, is the diagram. So there is a three layer. Okay, there is a three layer. First layer is a metal plate. After that the semiconductor will placed, then the third layer is a transparent foil of metal. In this metal On this metal only the light is incident. The light is from that may be any light, that may be a sunlight or anything. So some brightness. Okay. So if light is incident on the transparent metal, this light is go for this battery. So we can, and also the resistance and the battery is connected in series. Okay, connected in series. When the light is increased, the resistance will be decreased. If the light illumination is decreased, then resistance will be increased. Okay, here this is the working principle. In the absence of light, the resistance of a photoconductive cell is very high. When there is no light incident on this metal, then the resistance will be, what happened? The resistance will be decreased. Okay. So here the current is measured by using the ammeter. Okay. If the current is called dark current and the resistance corresponding to this called dark resistance. Maybe the 2 mark questions will be asked what is meant by dark resistance. You can refer this. Okay. So this is the photoconductive cell. So next one is a photoconductive cell application. The photoconductive cell where it is used means light sensitive alarms, faster recording situations, and automatic street lights, lightning control. All these are we already know. Okay. The productive cell, the photoconductive cell can be used for detecting the location of aircraft, and also ships with the help of radiation. That is, radiation is nothing but it's a wave. So light wave. Okay, that is coming out from their exhaust. That is, from their exhaust means from the aircraft or from the ships, the radiation is coming. From using that radiation, the photoconductive cell detect the location, and also they are used to either switch on or off the transistor in an electronic circuit. This is the simple one only. So next one is a photoconductive cell are used at the LED current level. To check the LED current level, we also use the photoconductive cell. So this is the common type of light sensor. Okay. So next one is a photovoltaic cell. So photovoltaic cell which is used in solar device. Okay. So here the solar energy and transform it into electrical energy. That is, light energy is converted and it transferred into a electrical energy. That is photovoltaic cell, which is made up of a semiconductor layer. Is the same as the photoconductive cell. So that also made up of a semiconductor device only. This is also made up of a semiconductor layer. It has been carefully processed to transform a sun energy into the electrical energy, that sunlight energy into the electrical energy. Here is the expansion to that photovoltaic. The photovoltaic means it's a combination of two words. The photo which is coming from the Greek word that is phos. Okay, phos. The meaning is light. Next one is a voltaic, which is derived from the name of Alessandro Volta, an Italian physicist who invented the voltaic pile. So forerunner of electric battery. Okay, the word is coming from the two different physicists. That is called photovoltaic cell, which is used in a solar energy, which converts the sunlight into the electrical energy. Okay. So this is the structure of the photovoltaic cell. So this is the solar cell. Here is the sunlight. The sunlight, which is the sun light and beam, is fall on the solar cell, right? This is the solar panel. So it consists of n-type material, p-type material, and in between the n-type and p-type material there is a p-n junction, right? So one photon is consist of hole and electron flow. Here is the symbol is called holes. This plus symbol is called electron. Okay, the flows in opposite direction. So here is this. Here is the elaborate explanation, that is structure which is given here. This is the solar cell. There is two strips, that is metallic conducting strips, which is connected to the voltage. For actual approximate voltage which is given to the direct current like 0.58 volt. So this is the n-type silicon and this is the p-type silicon. So the center yellow color layer is called a depletion layer. Actually this n-type and p-type silicon is produce the depletion layer. So this is the positive electron, and in n-type silicon is a negative electron. So we can call it as a substrate base. Okay, so there is a glass lens in this have. Okay, sorry. So this is the here is the sunlight. That sunlight is converted into the electrical energy. Okay, this light energy is converted into the electrical energy, that is shown here. Next one is the photovoltaic working principle. I already explained here. So which is working principle is same as the diode. So when light energy is greater than the band gap of the semiconductor used, the light get trapped and used to produce the current. Okay, in the absorption of layer of the cell, photons from the sunlight provide the electron energy. Okay, electrons energy, which causes the electrons break free from their atomic connections. So it produces the electron hole pairs. So after that, which pushes holes towards the p-type region and electrons towards the n-type region. So when an external circuit is linked, the space separation between the two sides generates a voltage potential, and that causes the electrons and holes flow, so producing the electric current. So this is the working principle of the photovoltaic cell. So next one is a photoresistor. So which one is a actually this photovoltaic is a active sensor. Okay, so this is the photoresistor and the photoconductive cell and also LDR. These are all the passive sensors. So that means it creates the power as itself, but in photoresistor it cannot create the it cannot generate the power. Okay, that is photoresistor. So the photoresistor is additionally called a mild based resistor. That is, here it consists of semiconductor material which exhibiting a photoconductivity and also allowing it to modify its electrical conductivity based mild intensity. Mild intensity is nothing but as a light intensity. So the light will be decreasing or increasing. You can also graphically say by low or high. Okay, so this construction of photoresistor is the primary structure and creation of photoresistor involve the light sensitive semiconductor fabric. Okay, this is also made up of a cadmium sulfide. Okay, in the absence of light, the LDR, that is light detector resistor, have very excessive resistance, about the several megaohms. In the presence of mild, that is the presence of light, it reveals a low resistance. Okay, when absence, the resistance will be increased. In presence of light, the resistance will be decreased. Okay, so that approximately some 100 ohms, but in absence it is several megaohms it has. Okay, resistance has. So this is the basic structure of a phototransistor. This is the strips that is made up of a cadmium sulfide. This is the two terminal, that is metal conduct. One is plus and another one is minus, and power and ground. Okay, this is a symbol of the photoresistor. Okay, so there are lots of types of photoresistors are there. So intrinsic photoresistor and extrinsic photoresistor, and other types have UV photoresistor, infrared photoresistors, and visible light photoresistors. So intrinsic and extrinsic will explain another section. So this is the working principle. The same thing will be provided here as a theory. You can refer for your exams. So next one is a light dependent resistor. Light dependent resistor is also a photoresistor only. Okay, it's the same only. So it's also is having it's made up of a cadmium sulfide and also using a semiconductor material, and changes its electrical resistance from several thousands of ohms in a dark to only a few hundred ohms when light falls. That is, if absence of light, the resistance will gives the resistance will be increased. If there is some light falls on the semiconducting material, it gives the decreased resistance. That is here explained that the net effect is an improvement in its conductivity with a decrease in resistance for an increase in illumination. The same concept as again and again is described. So next one is this is the LDR. So this is the two metal connecting metals. So this is the substrate. These are the thin strips of photoresistive material which is made up of cadmium sulfide. So this is the symbol of the LDR. That is it. Lots of difference between the photovoltaic, photoconductive, and LDR and photoresistor. So you can identify the symbols, then only you can write the exam without confusion. Okay, so LDR have 3 arrows. Okay, so here is the this is the illumination. Okay, x-axis is the illumination, that is light. So the dark means the resistance. Okay, so here when resistance increased, what will happen? The illumination will be decreased. If the illumination is increased, the resistance will be decreased. Here you can see here. So there is a low resistance, but illumination is high. That is, light is high, the dark is low. That is, resistance is low. So this is the dark night time. This is the average sunny day. Here is the bright sunny day. Okay, in average sunny day, it gives the results as per the light falling in semiconductor device. Okay, so these are also I explained the LDR working principle, so which is given as a theory. You can refer for your exam. So types of LDR are a photoresistor, that is already I told you, intrinsic photoresistor, extrinsic photoresistor, or we can also say the intrinsic LDR or extrinsic LDR. So a pure semiconductor without any doping, without adding any extra materials, means that is called photoresistance. Okay, if we add some materials, some impurities, then which is called as extrinsic photoresistance. Okay, so extrinsic light dependent resistors are generally designed for longer wavelengths of light with a tendency towards infrared. And also here the intrinsic photoresistance. So here this kind of photoresistor uses a pure semiconductor like silicon and germanium, but in extrinsic there is some impurities will add, okay, for make longer wavelength of light. Okay, so these are the two types of LDR phototransistor. So the applications of LDR is, which is generally used to detect the presence of intensity of light, used to automatic lights, and also switch on off according to the light. So simple smoke detector alarm and clock with automatic light optical circuit design, photo proximity switch, and laser based security system, solar street lamps, camera light meters, clock radios. These are the applications are which is used the LDR, light dependent resistor. Okay, so today we are discuss about the three topics. One is a photoconductive cell, next one is a photovoltaic cell, another one is a photoresistor, then LDR, that is light dependent resistor. These are the four light sensor we are discussed today. In next class we are discussed about the another interesting sensor. So until then, bye from Amuda. Thank you so much. If you have any questions or any doubts, drop the comments below. So for more lecture videos, visit our website smit.edu.in and also follow our Facebook page SMIT Chennai, our Instagram page SMIT_official_Chennai. Thank you.